Space is often described as infinite, an endless ocean of planets, stars, and galaxies stretching outward in every direction beyond anything the human mind can truly comprehend. That is what we are told. But when we look up with our own eyes, we don't see infinity. We don't see a glowing sea of light. We see darkness, a vast black void. That darkness feels like an edge, not the edge of the universe itself, but the limit of our ability to perceive it. From where we are right now, the farthest distance we can observe is about 46.5 billion light-years in every direction. That creates a perfect sphere around us, the observable universe, measuring roughly 93 billion light-years across. A light-year, of course, is simply the distance light can travel in the time it takes Earth to orbit the Sun. Light moves through space at a constant speed, and nothing can move faster than it. This is one of the most fundamental rules of the universe. So when we measure cosmic distances, we are really measuring time. Inside this vast sphere exists everything we have ever seen, measured, or known, and everything we ever will. And here, near the center of it all, are you, me, and every human who has ever lived. We are the observers, and that makes us the center of our universe. Now, this is where things begin to get strange, because the boundary that separates our observable bubble from the rest of the universe is not black at all. It is a wall of light. Not light as we know it, but ancient light, the very first light to ever exist. This light emerged from the hot, dense state at the beginning of everything, a moment we loosely call the Big Bang. That name is misleading. It suggests an explosion, but the universe did not explode outward into empty space. We'll come back to that. For now, all that matters is this, that first light still exists, and it surrounds us, marking the farthest edge of what we can ever see. So why does space look black? Because our eyes are limited. Light travels as waves, ripples through space. Imagine dropping a stone into a calm pond. Near the impact, the ripples are tight and sharp. But as they move outward, they stretch, flatten, and eventually become too subtle to see. The ripples don't disappear. They simply pass beyond our perception. Light behaves the same way. As it travels across the expanding universe, its waves stretch longer and longer. Eventually, they fall outside the range of human vision. Visible light becomes infrared, and then something even stranger. This is why we build instruments like the James Webb Space Telescope. James Webb can see light that our eyes never could. Deep infrared light stretched across billions of years. Through its eyes, space is not nearly as dark as it appears to us. It can peer back toward the earliest galaxies ever formed. But even James Webb cannot see the edge. Beyond the most distant galaxies ever photographed, the darkness remains. So how do we know there is light beyond that darkness? To answer that, we have to go deeper, far beyond infrared, into a form of light that is almost impossible to imagine. Microwaves, we are immersed in them. They arrive from every direction, filling all of space. Not the microwaves in your kitchen, but incredibly faint, ancient radiation that has been traveling since the dawn of time. This is the cosmic microwave background, or CMB. It is the first light the universe ever released, light that has been stretched so extremely by cosmic expansion that it now exists as microwaves. We cannot see it, but we can measure it. And when we do, we find this, a map of the universe at its earliest visible moment. The colors are not real. They represent tiny variations in temperature and energy. What this map reveals is that the universe was never perfectly uniform. Even in its infancy, there were slight differences in density, seeds that would later grow into galaxies, clusters, and vast cosmic structures. Most importantly, the CMB tells us the age of the universe. That light is 13.8 billion years old. And here's the problem. If light has only existed for 13.8 billion years, how can it now be 46.5 billion light years away? If nothing can travel faster than light, how did light outrun itself? To answer that, we have to return to the early 20th century and to Albert Einstein. Einstein's theory of general relativity defined how space, time, gravity, and light behave. But like many scientists of his era, Einstein believed the universe was static, unchanging, eternal. There was a problem. Gravity would eventually pull everything together. To fix this, Einstein added a term to his equations, the cosmological constant, a repulsive force embedded in empty space. And anti-gravity meant to hold the universe still. Einstein later called this his greatest mistake. He was wrong about the universe being static, but he was right about the force. In the 1920s, astronomer Edwin Hubble made a discovery that shattered the old view. He proved that distant nebulae were not clouds of gas within our galaxy, but entire galaxies of their own. Even more shocking, nearly all of them were moving away from us. The farther away a galaxy was, the faster it was receding. This was revealed through redshift, a stretching of light waves caused by motion, similar to the Doppler effect of a passing siren. Light shifted toward the infrared meant the source was moving away. Hubble's observations revealed something profound. Space itself is expanding. And not only that, it is expanding faster and faster over time. The universe is not flying apart through space. Space itself is growing. That repulsive force Einstein introduced, the cosmological constant, turned out to be real. Today we call it dark energy. Dark energy exists everywhere, space exists. And the more space there is between objects, the stronger its effect becomes. Eventually, this expansion exceeds the speed of light. Not because matter is moving faster than light, but because space is allowed to. This is how light that is only 13.8 billion years old can now be more than 46 billion light years away. Finally, we return to the Big Bang itself. The universe did not explode from a single point. There was no center. The Big Bang happened everywhere at once. All of space was once compressed into a hot, dense state, and then space itself expanded. Not into something, but into itself. During a fraction of a second known as inflation, regions of space expanded faster than light. A grain of space smaller than sand could have grown to the size of a galaxy in an instant. If the universe were a sandbox, every grain of sand would have expanded simultaneously, each becoming vast beyond imagination. And even that analogy falls short. The scale is beyond intuition. But step by step, thought by thought, this is how we begin to glimpse the true nature of reality. Not by seeing farther, but by understanding deeper.